Hello, everyone. Good morning, good afternoon, good evening, depending on where you're joining us from. Welcome to this webinar on exploiting infrastructure as code to target multi-cloud deployments. My name is Janakiram. I am the host for the MI2 webinar series, and today I'm very excited to bring you Joe Duffy from Pulumi. Before we get to that, I want to set some context. So one of the promises of cloud is programmability. And we have been experiencing this capability through potential SDKs and APIs that every cloud provider offers. But imagine the ability to write code that is not tied to a specific cloud, but using an SDK that is truly multi-cloud and can target the cloud of your choice with the language and the toolkit of your choice. That's what Pulumi is all about. So it's a pretty exciting technology, pretty exciting platform. I'm really looking forward to see this presentation and see the exciting demos that Joe is putting together. But before we hand it off to Joe, let me give you an introduction to MI2. So MI2 focuses on two very interesting trends. One is machine intelligence and the other one is modern infrastructure. Machine intelligence is all about IoT, AI, ML, cognitive computing, machine learning, and of course, neural networks and all things related to AI. Modern infrastructure is predominantly Kubernetes with surrounding technologies like the cloud native services like Istio, Prometheus, and a variety of other projects predominantly coming from the CNCF stable. So I covered these two in an alternating fashion. Today's track is all about infrastructure, and that's why we're talking about infrastructure as code. The webinar is complemented by a tutorial, code snippet, and a video. So you can actually watch this on my YouTube channel in a day or two. And most of the demos that are going to be shown will be made available to you. I will request Joe to share the links and it will be updated on the description section of the YouTube video. This is completely an independent and neutral platform to explore emerging technologies. I don't have a marketing agenda to drive the technologies or the demos or the presentations. It's purely meant to bring you the latest and the greatest technologies from the field of machine intelligence and modern infrastructure. So one quick housekeeping poll before I hand it off to Joe. So you're going to see a poll, and do let us know if you have difficulty in the AV experience. Okay, looks like everyone is able to follow and you're experiencing better AV. Fantastic. So I'm going to end this poll and turn Joe into a presenter who will walk us through Pulumi's technology. So, Joe, all yours.
Great. Thanks, Janakiram, and thanks everyone for joining in. Excited today to talk to you about modern infrastructure as code and how that applies to multi-cloud and some of the challenges we see. Before jumping in, I wanted to give a little bit of background on why infrastructure as code is exciting and why Pulumi is slightly different than what you might already be familiar with. So we see today, this modern cloud transformation where we're going from a world of largely virtual machines, on-premises, private clouds, and really trying to get to this more hyper-connected sort of dynamic world that really has a lot to do with the container movement, and Janakiram mentioned Kubernetes, a lot of public cloud, but we still see that there's a fair bit of hybrid cloud as well. And some of the challenges with this trying to, this transformation is that it does lead to a lot of silos is what we see. We see that it can lead to technical silos where, every cloud might have its own set of tools and workflows, might have its own DSL, domain-specific language, or YAML dialect for how you configure the infrastructure. These languages typically are not really expressive, and so they don't have great tooling around them. It's hard to share and reuse best practices. This leads to this feeling of always reinventing the wheel. Every time you face a challenge, you're copying, some scripts or markup that you use somewhere else. This also leads to organizational silos. We see that, modern cloud engineering organizations have developers, infrastructure engineers, operations teams, security engineers, and we find that it's hard for them to collaborate in this world. Everybody's using different tools. They're speaking different languages, quite literally. And because of the security team being out of the loop, this also tends to make solutions kind of insecure by default. And overall, this just has sort of this dragging down effect on the whole organization, where we can't move as fast as we want to, and we're shipping new features every quarter where we really want to be shipping them every day. We also find after you get through this journey of kind of moving to the public cloud, we find that maybe it wasn't as transformative as you expected. Maybe you're not getting everything out of that transformation that you expected. So infrastructure as code is a structured approach to automating how you manage your infrastructure. There's a lot of infrastructure to manage. There's from the Kubernetes cluster itself to all the networking to all the security, the monitoring, the logging. Then you move up, and there's maybe serverless in the picture, maybe API gateways. There's databases, pub sub topics and queues, and Docker images and private registries. There's a lot to manage in sort of the modern cloud environment. So there are a few ways to tackle those challenges. Most folks are familiar with going into the AWS console, point and clicking to spin up resources. That's not very automated. So the next step in sort of the maturity level is maybe automating using scripts, or maybe the CLI for your cloud. But infrastructure as code is a way to really encapsulate your infrastructure requirements to provision or configure that infrastructure using code. And it takes a different form depending on whether you're taking an immutable infrastructure approach, which is typically in the modern cloud infrastructure, you've got containers and serverless, where instead of changing infrastructure in place, you're doing sort of replacing that infrastructure on the fly, versus more of the mutable infrastructure approach, which is kind of where most of our stuff coming from, which tends to be very VM oriented, where you might be patching servers, for example. So today we're going to focus more on provisioning. And to highlight this example, just imagine you want to upgrade a web server from V1 to V2, maybe a new version of Apache. Well, the configuration way that we're all familiar with, using tools like Chef, Puppet, Ansible, Salt, we would upgrade the server in place. The challenge with this is if something fails partway through, how do we get back to a well-known state? Have we tested all possible combinations of where we're coming from and where we're going to? It's challenging. We've all faced these challenges. The provisioning way, which is definitely in the modern cloud architecture, is what most folks that we talk to are moving towards. You would just deploy a new instance of the web server, change your load balancers to point to that new instance of the web server, and then tear down the old one. This is more easily testable. You know that you're provisioning a well-known state, and so if failure happens, things happen. Network outages happen. Sometimes infrastructure is flaky. Maybe a region within AWS is having problems when you chose to deploy, et cetera. All these unexpected problems happen. If a failure happens, we at least are restarting from a well-known state. So that's what we're going to focus on today. I would say before hopping into the Pulumi and some of the more modern infrastructure as code approaches, just know that there are a lot of, when we say code, that I put that in quotes here because there's a lot of different approaches to infrastructure as code. There's using YAML or JSON. There's domain-specific languages, and what we'll see with Pulumi is you can use, general purpose languages like Python, JavaScript, Go, C#, etc. All of these share some benefits, which is that they're automated, they're repeatable, and we can review and version our infrastructure changes just like we do code. In Git, we can do code reviews, all of those great things that we get about, that we know about application code, we can now apply to infrastructure. Here's sort of a landscape just so you can anchor sort of some of the different technologies out there. If you're using AWS, they do have, AWS has CloudFormation, Azure has resource, ARM templates, Google has Deployment Manager. Each cloud has their own native way of provisioning infrastructure. The challenge there is each one is different. So if you have to deal with multiple clouds, either now or in the future, you're going to be having to retool and recode in different tool sets. And as you get to things like security and you want to secure your workflows or do CI/CD, this is a challenge because now you have to do it N different ways. And if you're doing it on-prem, it's yet an even different set of tools. The more cloud independent set of technologies include Kubernetes, right? So for the subset of infrastructure you can express in Kubernetes, it's great. And you get YAML, Helm YAML templates, which have some DSL capabilities built in. A lot of folks are familiar with Terraform, which has its own domain-specific language. And what we're going to look at today is Pulumi that uses general purpose languages. So I mentioned modern, and what does modern mean? So I really wanted to spend just a moment talking about that, and then we'll jump into some code and we'll see this in action. So, what we're seeing is really three things add up to being a modern approach to cloud. Whereas there's modern architectures where we might hear the term cloud native. A lot of new companies, new innovative startups that are just starting today have the advantage of being able to just start with the cloud. A lot of folks are trying to move to the cloud and move more towards this world. We also see that it's not an or, it's not VMs or containers or serverless. We really see a lot of hybrid architectures where you're using a combination of those things. You're using the best of all of these different services together. And we also think, newer architectures, the infrastructure actually starts to become part of the application architecture. You think of using AI services or containers and microservices, that really is impacting the application architecture itself. We see modern teams, this is really working together to move faster, to deliver things continuously across developers, infrastructure teams, operations, and security teams. And then modern workflows are increasingly multi-cloud. And to me, the workflow is the key thing here. So when some folks talk about multi-cloud, they're trying to sort of abstract over all the different clouds and code to the lowest common denominator. That's not really what I'm talking about here. What I'm talking about is the languages that you're using, the deployment tools and techniques and methodologies you're using are consistent. The way you secure that is consistent across public, private, and hybrid clouds. And that's really key because now your whole team can sort of standardize on the way you do things, while still taking advantage of all the capabilities that make each of the different cloud providers great. So the way this goes in terms of the infrastructure as code is, it's really three steps that we're going to take. First, we're going to create our infrastructure. We're going to provision it. So we author that in a language, and we'll see today, we'll see JavaScript and TypeScript today, we'll see Python today. But there are other languages available. If you're doing this in Terraform, for example, you would be using a domain-specific language, but the workflow is similar. Then you deploy these changes, right? And deployment, what we'll see today is a very command line driven deployment, but Pulumi has CI/CD integration. So if you want to deploy from GitLab pipelines, for example, that's easy. And then we'll manage the changes. So we'll see that there's a full audit log of who changed what on my team and when. I mentioned the different languages. I think, a lot of teams have languages they're already using, and so it's really great to be able to just continue using that language you're familiar with. And really, being able to use that language isn't just about the language itself, right? So what we find is, infrastructure is software these days. That's kind of what the public cloud has done. It's given everything an API. And so, on AWS, every single service that they ship, there's always a great API there that you can use to program the infrastructure. This hasn't always been the case, and I think this is one of the key changes that really enables infrastructure as code to exist in the way that it does. We see that I mentioned application architectures really are incorporating more infrastructure, and that's a key change that's happening now. That in the past it was you could write an n-tier application, kind of throw it over the wall, and then the infrastructure team would manage provisioning the VMs to run those. We see these days teams want to empower their developers to be more self-serve so that they can move faster, but with guardrails, right? So that with making sure that developers use the team's best practices and that policies are in place. I think the unique approach that Pulumi takes that you'll see today is still having a declarative infrastructure as code model. So infrastructure as code for provisioning, really what it does is it tells a deployment engine that says, hey, you know, I want this desired state, this goal state. It says, hey, I want 3 virtual machines. I want a security group. I want a load balancer, a Kubernetes cluster, you know, make it happen. And then the tool kind of takes that specification and carries it out. By using programming languages to express that goal state, we get all the things we know and love about programming languages. We can use types, we can use functions, classes, we can have packages, so we can codify, you know, common patterns without having to repeat them. We can have for loops, you know, so if we want to create 3 servers, and we'll actually see in just a minute, you know, creating a virtual machine for every AWS availability zone, which is just a for loop. You can have conditionals, so maybe your staging environment is just slightly different than your production, for example. But I mentioned it's not just about the language, it's also the tooling ecosystems. And so you get access to package managers and existing libraries. So, you know, computing CIDR blocks, for example, you don't have to, you know, do that by hand. There are existing libraries you can just tap in to do that. You get IDEs, you can test code, you get code coverage. And of course, you've got training and online communities, right? You can ask questions on Stack Overflow, and it's just, you know, a normal programming language that folks are already familiar with. And so that's really a great benefit. Also, we just see that it's just a whole lot less code, right? So this is kind of a little example of, you know, provisioning. On the right-hand side, this is kind of Pulumi creating a security group in Amazon. And this is written in Python. And notice that, you know, it's pretty familiar for, you know, Python code. And then if we want to create, you know, an instance for every availability zone in Amazon, we can just say, hey, you know, loop over the availability zones and create an instance. This kind of code on the left is the equivalent CloudFormation template, which doesn't have loops. It doesn't have sort of a type system built into it. So it's just a lot of code. So it's very common to see, you know, a factor of 10x reduction when you're moving from these templating languages to infrastructure as code. And it's even true of, you know, domain-specific languages. So, you know, often, you know, when you move from Terraform to adopting Python or JavaScript, you can more easily share and reuse, you know, common patterns that are occurring. And so we often see a significant reduction there as well. And so with that, why don't we jump into a quick demo? And so I'm going to open up Visual Studio Code. And so this is, you know, you'll see here, this is great because, you know, we're able to just use a language that we're familiar, I mean, an IDE that we're already familiar with. And so I'm just going to walk through this very quickly. So this is Node.js. We could have used Python, Go, or .NET. So first, we're importing a package. And notice that it's just a normal NPM package, actually. And what we're going to do is we actually see that we get interactivity right out of the box. So, you know, if you need help, you know, what is an instance type? You know, we can actually get all that information as we're typing. And that just happens right out of the box for every package. And there's also packages, because this is multi-cloud, I'm showing a lot of AWS today, but it works just as well on Azure. So I can say Azure here, or, you know, GCP or Kubernetes. In fact, there's over 30 different cloud providers that you can choose from. So we'll go through quickly. So we're creating a security group here, specifying some ingress. And notice I'm also getting documentation right in line here with links back to AWS. So I don't have to have a separate window open with documentation all the time. You know, if I mistype something, you know, protocol, if I mistype that, I'm getting an error message saying, hey, you mistyped that. And so it's really quick to just like get interactive feedback on what's happening. I can actually, this is programmatically getting the latest version of the Amazon Linux AMI. So that if the AMI changes, my program is going to pick up the latest, and I'll see that when I go to do a deployment. I'm going to create a web server, and interestingly, notice that the security group here, it's actually just using the security group that we defined up here, and just using a property there. And so we can actually have dependencies between resources as we're coding up our infrastructure. And then we're just going to export the resulting public IP and hostname. And notice that this runs a simple Python web server. So I'm going to open up a terminal window here. And I've already set up a stack. So Pulumi has the concept of stacks. And so my project that I've got open here, any number of instances. And I'll go ahead and deploy to region in US West 2. I can easily reconfigure that if I want. So I'm going to run Pulumi up. And that's the command that effectively runs my program, computes the desired state, and then lets me choose whether I want to do the deployment or not. I selected yes because spinning up a web server takes a minute. So while I'm talking, I want that to happen in parallel. So what it does is it shows me what it's going to do before it actually does this. This is basically a plan. So if something doesn't look right, I have an opportunity to say, no, that doesn't look right. In a CI/CD setting, this can actually integrate with things like GitHub pull requests. And so you can see the changes that are going to happen to your infrastructure before you make them. And notice, I performed the update, it says yes, and it printed out, the host name and public IP. The web server is probably still booting up right now, so I'm not going to curl it or anything, but I could just as easily. So that's great. It spun up a web server, and that was easy in a security group. But let's go a little bit beyond this quickly. So what if we wanted to create a web server for every availability zone in AWS? Well, that's actually pretty easy. We could say we're going to set up arrays here that we're going to export at the end. And then we're going to say get availability zones, the names. And then we're going to loop over the availability zones. And then we're going to just create a web server for each one. And we have to specify here that we're going to put it in the right availability zone. And then each server needs a unique name. So we're going to give it that name here. And then we'll want the tag here also to have the same name. The one last thing is server public IP. We want to keep track of these because we want to export all of them. So, sorry. See, it caught a mistake for me, so that's great. And then finally, we just have to export these variables at the very end. So provided I didn't mistype anything, this should, now when I run Pulumi up, it's going to show me the delta. So we already provisioned a security group and a server, and so the security group didn't change. So what are we going to see? We're going to see, okay, we saw that there's no change to the security group, so it doesn't show up. It's going to create a web server for each of these different regions. And you can see, the region here, and it's going to delete the original one. Why is it deleting the original? Well, the name changed. And so it's showing us that it's going to create 4 web servers. And it's showing us here, hey, we're going to export the 4, different servers. Again, this is web servers, this is virtual machines, so maybe not as exciting as maybe, containers or serverless, but any infrastructure or Kubernetes clusters for that matter, any infrastructure is done the same way. Notice also, interestingly, that it's already run, it's already created all of them. It's doing that all in parallel as well. And so the Pulumi runtime understands dependencies between resources. And so it understands that all of the instances depend on the security group. And so it needs to do, those operations in a certain order. But it knows that all the different instances actually are completely independent of one another. So it can go ahead and actually provision them in parallel with one another, and then it's now deleting the old web server. And deleting the web server can take, a moment, and so we won't have to wait, around for that. I'll just show you quickly. This is another example that's using is creating a ECS Fargate cluster in Amazon. It's creating a load balancer. It's actually building and publishing a Docker image from my local project here, and it's publishing that to a private Amazon registry. Then spinning up a Fargate service in Amazon. So this is a service that will be load balanced and scaled out to 5 instances, and then it exports the host name. And that would work very similarly. I just run Pulumi up. The interesting thing there is it actually would build and publish the Docker image for me in addition to doing the infrastructure. And as I mentioned, with all the dependencies, it understands the right order in which to do all those things. And then we'll see here, this finally finished, and we've got all the public IP addresses. For fun, I can try curling this. It may not have come up yet, but I'll try anyway. Yep, so that came up, and it's up and running. All 4 of them are. Next step might be to throw a load balancer in front of these 4 web servers, since they're all in different AZs, and get some nice load balancing going on. That would be really simple to do. But for time purposes, we'll call it quits, and we'll go back to the slides for now. So we saw there, infrastructure as code. We saw the benefits of using a language. I just wanted to point out, all of the different tools that you get access to, right? So if you're already using any of these, you can now, in your organization, you can now apply them to infrastructure as well. You get linters, testers. You get to use your favorite IDE. I use VS Code, but if you prefer JetBrains or Vim or Emacs, you can use those. Package managers, if you're already using, say JFrog, for on-prem package management, you get access to that. So it's really this whole ecosystem of tools that goes beyond just having the language itself. Also being code, I've alluded to this a few times, but you can more easily build and reuse components. And so we'll see later, actually, I'll take that web server example and I'll package it up into a component that can be shared. And when it comes to multi-cloud, we can actually use that to do some fun things like, I mentioned we don't want to be a lowest common denominator, but in some cases you might be able to create components that make sense to run in different environments. Like maybe you care about running in Kubernetes on AWS and Kubernetes in Azure, and maybe there's some storage that you can abstract or services you can abstract between the two. And again, it's just using regular programming languages. So you can use classes, you can use functions, you can take those results, throw them into a package manager, and more easily share and reuse them. Testing is actually really powerful. We find a lot of folks now using testing because now that you've got a real language for your infrastructure, you can test it just like we would for application code. And this takes many forms. It takes the form of unit testing, just making sure your code is doing the expected things. Policy as code. So Pulumi does have policy, which allows you to do security, costs, governance, compliance, and basically ensure that your infrastructure has certain properties so that you're not accidentally deploying mistakes. This is also great when you're an infrastructure team trying to empower developers to be more self-serve. Because you can know, hey, even though you're giving them the ability to do deployments, that it's going to obey important policies in your organization. There's integration testing. This kind of takes 2 forms. One is what I call ephemeral infrastructure testing, where you spin up an entire environment, validate it, and then tear it down. And we make that easy to do even in, say a pull request on GitHub. Maybe you want to spin up an entire copy of the environment, smoke test it and then tear it down to make sure that it works correctly. And then obviously deployment verification. After deploying to a long-lived environment, you may want to run a set of tests. And so that's an important part of the infrastructure as code lifecycle as well. And then there's a whole host of other advanced testing scenarios like stress testing, performance testing, even fuzzing, right? Seeing what happens if a critical piece of infrastructure were to fail. That's another thing that becomes easy because it's just code. You can put in place arbitrary logic in your program. So let's look at sort of some of the multi-cloud workflows and how modern infrastructure as code can help with them. The way we sort of view the ecosystem, again, with real languages, everything is just a package. So the foundational layer that I was showing you the AWS package. I mentioned there's Azure, Google Cloud, Kubernetes. There's a lot more, right? So when you're programming at that layer, you have full control. You understand everything about all the resources that you're tapping into, and that's great. Again, to my earlier point, we don't want to abstract over what makes each of these providers great. But we do want to eliminate some of the tedious aspects of managing those infrastructure components. And so, we have all these patterns out of the box for how to do containers. I mentioned building and publishing to private registries. Well, that was literally one line in the program I briefly showed, and it was one line because there's a package, there's a library for that. Similar for serverless, uploading a new AWS Lambda or Azure function or Google function, requires packaging up code in a zip file, uploading it to a blob store, connecting all those pieces. It's a lot of tediousness that leads to, infrastructure bloat, infrastructure as code bloat. And so removing some of that tediousness is key. And then at the very top, we can basically aggregate all those things into very easy to use components that have built-in best practices. So let's jump in and let's look at Kubernetes briefly, because that's a key element of multi-cloud. And so again, I'm going to open up VS Code. And in this case, I'm using something entirely different. So this is Python, not JavaScript. And this is GCP. So basically what this program does is, it's got a bunch of configuration. So I showed earlier you can configure, I showed the AWS region in the config. Well, it turns out you can create your own config as well. So if one of your stacks has 3 nodes in the cluster and your production stack has 10, we make that easy to sort of configure on a per stack basis. And so this kind of goes through it and does all of that. This here spins up a GKE cluster in Google Cloud. And then it produces the kube config and exports it. That actually takes a minute. We'll see Pulumi config. So we'll see, we're going to do master version. You can see all the region information. So again, I have to enter into the virtual environment because this is Python. So I will go ahead and say Pulumi up. And it's going to say, hey, we're going to create a cluster. It turns out, the workflow here, notice even though we're using a completely different language, we're using a completely different, cloud, we're now using Kubernetes, we didn't actually have to change anything about the workflow here, which is really great. It means no matter which cloud we're going to, even if we're using Kubernetes, we can just use the same set of tools. And again, if we're using CI/CD, it would work the same. So that's going to chug away for a minute. And what I'm going to do is I'm going to grab some code I already have baked up here. And I'll add that. And in parallel with this going, I'll show you what's happening here. So what we're actually going to do is, this is spinning up an entire new cluster. What we're going to do next is we're actually going to deploy Kubernetes objects into that cluster. Now, often this would be a different program, and that's fine. Pulumi makes that easy to have different projects. You don't always want to deploy the Kubernetes services in the same infrastructure program you have your cluster defined in. But it turns out actually sometimes you do. In this case, it's just a canary deployment. So maybe we want to do this because we want to make sure the cluster is actually working. Or, even more common is, a cluster isn't fully configured until you've deployed some services into it, maybe Prometheus, for example, maybe an ingress controller. It also turns out, if you're doing, say, EKS in Amazon, you might want to provision some Amazon services, like maybe you want to provision CloudWatch dashboards or log groups. And being able to do that in one consistent language, you can actually have dependencies between these different objects, right? So Pulumi is going to know when we do this that this is a Kubernetes deployment object. And it's going to know that deployment is dependent on the cluster. And so it has these cross resource dependencies, which is critical to being able to do a correct deployment. Usually how this happens is people will have to write bash scripts that have timeouts and waits in them and polling and all these things, whereas Pulumi just kind of takes care of that for you because of the ability to use one consistent workflow. So see, this is actually a Kubernetes deployment object. Notice we're getting the full Kubernetes, documentation here as well. So just like we got the documentation for AWS and Google resources, we're going to get it for the deployment. You see, replica count. It's going to create an ingress controller. And then what it's going to do at the very end is export the IP address. And so this will continue going along just for a minute. And we'll show that in just a minute. Why don't we go back to the slides, because this is gonna, I think, usually it takes 5 minutes or so. And so when we come back, it will be ready to go. I mentioned the continuous delivery aspects of infrastructure as code. And so typically what you would do is, so we've shown the CLI-based workflow. Typically the next step is, that's great for development, right? Coming up with a new project, or, sometimes deploying to your test environments. But oftentimes the next step when you go to production or create long-lived environments like staging, you're going to create, you're going to want to do CI/CD. And the way that we sort of go about that is Pulumi integrates with a lot of different CI systems. So typically you're coming from GitHub or Atlassian or GitLab. You're going to use the code review workflows there to version your infrastructure as code, to review it as a team, to approve it. And you're using whichever language you've chosen. And then once you check in, once you merge a change, that typically kicks off the CI/CD workflow. This is going to do the testing and then ultimately the deployment. And so you could be using Jenkins, Travis, CodeFresh, Spinnaker. You might be using, the built-in like AWS code services or Azure DevOps pipelines or Google Build. Any of these options work just great. We kind of want to accommodate whatever CI/CD system you're already using. And then of course, whatever the environment is that you're going to, that kind of works consistently. I mentioned this enables this sort of GitOps style of infrastructure management, where you can actually version your infrastructure like you do code, and then actually see in a code review setting sort of what the impacts are going to be before you make those changes. So it really helps the whole team collaborate around the infrastructure changes. And we're actually going to see in just a moment a concrete example of that. The other nice aspect is, because you're doing this as code, just like you always have a full commit log for every change made to code, you're going to have a full deployment log of every deployment that was ever made. You can see who did that deployment, where it came from. You'll even see here, notice these little cards here, notice they link back to the commit. So this actually links back to GitHub, so I can actually see the code change that triggered the infrastructure deployment. We'll see the branch, we'll see pull requests and all this. And we'll actually see a live example of this in just a minute, because we actually use Pulumi to deploy the Pulumi service itself. And so our team actually uses this on a daily basis to do deployments. So why don't we take a look at that? I think our cluster probably is done deploying here. Yep. So our cluster is done deploying. Notice it exported the kube config. Whoops. So Pulumi has the notion of stack outputs, which you've been seeing, but the nice thing is you can actually export. So we'll see the kube config YAML here, and we can say actually kube config equals kube config YAML, and we can see, get pods, right? So this is actually going to get the pods in our cluster. There aren't any because we haven't deployed anything. So let's quickly deploy the deployment object, the canary, and the service. So this is actually going to deploy those services, the Kubernetes objects and configuration, into the cluster that we just created. And interestingly, you'll see here, the Kubernetes provider is actually giving us rich status updates as the deployment happens. So it's actually finding pods, allocating the IP address. We'll see, when it's creating a load balancer for the service. And this IP address, it's actually running in Google Cloud, right? So the IP address is being allocated in GCP itself. And Pulumi is able to give us these detailed bits of feedback. It'll also tell us if something fails, which is also really useful. I can't tell you how many times I've deployed, using kube control, deployed a new service and mistyped the container image name, and then it just sits there in a crash loop, and I have to then be running kube control commands to find out what's going on. Well, with Pulumi, it will actually tell you right then and there, hey, your deployment failed because the container image name is wrong. If we scroll up, we'll see that the ingress controller was created, and so there's an IP address. And so if I actually curl the IP address, we'll see, this was just, I kind of glossed over that, but this was just deploying the stock Nginx image. And so we see that Nginx is actually running in our cluster. I should mention, if I want to destroy things, I can run destroy and it will tear everything down. So, but let's see this demo here, the infrastructure pipeline demo. So I'm going to just go back to the web server and just open up a quick example of what we use internally to do deployments. And so this is just on GitHub. This was a staging release that we deployed 23 days ago. And we can see, if I look, there's going to be a lot of, file changed and a lot of commits that are going out. Some of this is application code, some of this is infrastructure code. But what we'll see is Pulumi, when the pull request gets open, Pulumi annotates the pull request and says, hey, if you deploy this, it's going to update, the ECS service. It's going to replace the, task definitions. And it allows us to look at this as a team and say, hey, are these the intended changes? Is this what we expected to happen? And if not, we can say, hey, no, this doesn't look right. Let's make a change. It also links over to Pulumi. So we'll see the Pulumi console here. And this is effectively, just showing us the same thing we just saw, but we can drill into the details if we want. It also links to, we were using Travis as our CI system. It links to all the systems, and it links back to the commits and everything that we just saw. We can also see the current resources that are live in the stack. We can actually even see there's a graph view. So if we want to build, look in, oh, there's a bucket, it's replicated. We can see all this information. We can click on over to get to the AWS console. And so it's really nice that all of this is just integrated. And I didn't want to spend too much time on that, but I did want to show you because I think most teams that are deploying infrastructure in production are doing it that way. And Pulumi gives you a lot of tools for managing different environments, and promoting between staging and production. You might have noticed in the previous screen when I was walking through that it was actually promoting to staging first, but then it showed us a preview of what would happen if we then went and deployed that same change into production. And so we can more easily kind of understand the totality of different environments that we're going to. And the final thing I wanted to touch on multi-cloud, what we're seeing a lot in infrastructure platform teams using Pulumi to essentially build a platform as a service for their organization that developers can then use, the infrastructure team can use, that sort of has these components and reusable infrastructure abstractions that codify the best practices for the company, have built-in policy and governance, but also allow developers to be a little bit more self-serve. And it also helps to tame some of the multi-cloud difficulties. And I'll show you sort of a toy example of this. It's not, this is just something that fits on a page, but it should give you a little bit of an idea of some of the things that are possible using this modern infrastructure as code approach. So what we see here is really quite interesting. What we'll see is this code is just going to allow us to configure So this is the Pulumi config system. We're seeing this we saw this just in Python a minute ago, but this is the Node.js version. Again, it's still going to deploy a simple Python web server. But what we're going to do here is we're going to say, hey, let the deployment time decision happen as to whether this is an AWS web server or an Azure web server. And then, we could add any number of web servers here, or we can do a Kubernetes version or a GCP version. And then no matter what kind of web server it is, we're going to export the public IP. And why don't I first show you? I'll start the operation here. Actually, I'll do it from over here so we can see it as I'm talking. So we've got a stack already called dev. And why don't we set the cloud to AWS? And then we'll set the AWS region to US West 2. So when we're pulling up, it's actually going to do the usual thing. It's going to show us, the infrastructure. And interestingly, so we'll say yes. Interestingly, notice here we have this multi-cloud web server, and inside of it, it's got an instance. This is something we call a component. So Pulumi has the ability to have components, and we'll see what that is. That's here. So we set AWS, right? Because we configure the cloud. So it's creating the AWS version of the web server. So we go here into the AWS folder. We'll see, well, okay, what is an AWS web server? Well, it's actually extending this base class, which is coming from here. So we've got this abstract class, which is a web server. And that's why we can get the public IP no matter what kind of server it was. It's because it's this function that AWS and Azure versions of the server implement. And so we're back on the AWS. So what is an AWS web server? Well, it's really just doing the same thing we saw in our original demo, which gets the latest Amazon Linux AMI and provisions a new instance. Notice that it's hard coding the T2 micro. I mean, you get to decide here what parameters you want to take. So you can parameterize the server any way that makes sense for you. In this case, we're just allowing you to pass in the script. Notice also that it's going to create a shared security group. So if we create multiple servers, they're all going to share the same AWS security group. And we see down here, it actually already finished. And hopefully, as I mentioned earlier, sometimes, yeah, so that it's up and running from AWS. But what if we wanted to create an Azure web server? Well, we can say set cloud Azure, Azure location West US. And now we say Pulumi up. So long as I didn't mistype something, we're going to see basically the same thing, except we're going to see a lot more resources, because with Azure, we have to create the network card, the interface. So see that we're creating a public IP, a network interface, a virtual machine, a resource group. So, but now it's chugging along and actually deploying all these changes to Azure, which is kind of cool. We didn't change the program. All we did is configured a new stack and selected that different cloud. And if we go in here, this is the Azure version of the web server, which is going to look, pretty similar, except it's going to create, a public IP, network address, and again, all these parameters are here, but you can make them, configurable. So, the VM size is here, which is just the standard A0. So there's a lot going on here. It turns out get public IP for Azure, you've got to implement it slightly differently than, on AWS, and it needs a resource group. But again, you're able to go deep and access everything that Azure has here in terms of resources, but you were able to make an interface that made sense for you. And a lot of our, what we're seeing for these infrastructure platform teams, maybe they're creating an environment for their developers to spin up, new environments. Maybe an environment contains a Kubernetes cluster and all the networking base layer and all the IAM security. And now a developer doesn't have to think about, oh, what's the difference between that environment on AWS versus on Azure? The infrastructure platform team can decide that. Or maybe they come and say, hey, I want a new microservice. Well, what is a microservice? You kind of get to decide. And so this is sort of the best of both worlds, because you're getting these nice higher level abstractions, but you're not completely papering over kind of all the details, so that it's not a lowest common denominator approach, and yet it's still giving you the ability to tame some of that complexity. So virtual machines typically take a little while to spin up, so that's going to keep chugging along, but I'll go back to the slides now and start wrapping up. So I think we've seen a lot of stuff today. Hopefully it's been exciting. We learned some of the challenges with modern cloud environments, whether that's architectures, the teams, the applications. We saw some of these approaches really do help break down those technical and organizational silos. We saw what infrastructure as code is and why modern infrastructure as code using general purpose languages is a great tool for provisioning, deploying applications in infrastructure, also enforcing policies and testing your infrastructure. It's an important part, bringing more of that software engineering discipline to infrastructure management. And then finally, we saw, some approaches for taming multi-cloud complexity. That includes, having consistent workflows for how you deploy and version infrastructure, how you review those changes in your team, whether it's, CI/CD or, in some of these pull request workflows. We saw that Kubernetes is an essential component to doing that. And I think, the best part is, really once you adopt this approach, the whole organization can work together to more rapidly deliver features, deliver infrastructure changes, deliver new application versions as well. So with that, I'd like to turn it back to Janakaram and open it up for any questions and conversation.
Great. Joe, this was fantastic. Particularly your last demo was very, very exciting, and it's so relevant in the context of programmable infrastructure and also creating a programmable polymorphic layer on top of specific cloud implementations. I love the fact that you can actually create a base class called web server and then inherit that to create multiple versions, which is just phenomenal. So we don't have a lot of questions, but I want to ask you, how do developers get started with Pulumi? What is the best path to get their hands dirty, to get started with the whole infrastructure as code?
Yeah, I would say, Pulumi is open source. I didn't mention that yet, but it is open source, and so it's free to use. If you go to pulumi.com, on the link here, there are these getting started guides. So you go to pulumi.com, click get started. It will walk you through downloading the open source tool. And then the cool thing is the next step, it has these getting started tutorials for AWS, Azure, Google Cloud, and Kubernetes. We also have, by the way, tutorials for, if you want to use vSphere, maybe you're doing on-prem, OpenStack, or if you're doing Alibaba Cloud or other cloud providers do exist, but those four are primary ones. And so you walk through that, and it will actually just, it basically says, hey, pick your favorite language. And then no matter which language you pick, it will walk you through basically a simple task of, spinning up an S3 bucket and then securing it, or spinning up a web server or a new Kubernetes service. From there, there's, hundreds of tutorials for more interesting infrastructures that you might want to explore after that.
Perfect. Awesome. So what do you see as the roadmap? Is this going to be completely integrated with source code? Is the future of infrastructure source controlled code that is going to be alongside the application code? Is that where the industry is moving?
Yeah, that's what we see, and definitely we're big believers of that. I think, picking general purpose languages and tapping into existing communities, existing tools, for infrastructure teams, it's just a huge level up. It gives you so much more capability than you had previously. it removes a lot of the pain of managing infrastructure. Even the best tools we have today, you think of Terraform, for example, there's a lot of copy and paste that happens. And so it helps you to sort of really be a lot more productive and know that you're doing it securely and following your own best practices. From there, though, it means that the application developers are able to then change infrastructure. And you may want that, you may not want that, but a lot of organizations want a little bit of it. So it allows you to give your developers a little bit of more control. I'll say also, if you're a small company, like a lot of our customers are tech startups that just got started, and they don't necessarily want to have different infrastructure teams and development teams. They just want to say, hey, team, work together to build a new cloud application. So it works for the full range of whether you're a large company or a small company. And I think the architectures we're seeing emerge with containers, microservices, Kubernetes especially. Kubernetes has kind of forced the issue of being in the developer's inner loop. It really brings infrastructure closer to your application. A lot of components in your application actually are, quote, infrastructure, right? If you're doing AI, ML, if you're doing, if you're sending email using MailChimp, that's something, that's code you would have written that you now don't have to write, but it requires infrastructure to do that. And so not having to completely step outside of your tool chain that you're familiar with already really helps the application infrastructure to be one and coexist a little bit closer together.
Perfect. So there is one question from the audience. So how to validate resources before they're going to be deployed? I think the question is more towards a pre-flight check.
Yeah, so I kind of gloss over it a little bit. So we have this policy as code feature where, just like infrastructure as code, you write in your favorite language. The policy as code, you write in your favorite language as well. And policy, you can write unit tests and things like that using whatever test framework you're familiar with. So if you want to use PyTest, you can use PyTest. We also have this policy as code framework, which allows you to basically apply policy independent of writing the infrastructure as code. So what you could do is say, hey, I've got these policies, S3 buckets need to be encrypted, don't allow, ingress rules that are open to CyberBlock 0.0.0, open to the internet. You can write those, we call them policy packs. And then you can go and say, hey, apply this across my whole team. So anybody who's deploying has to follow these policies. And then the Pulumi, when you run Pulumi up, it will actually check with our server and say, hey, what policies need to be applied, and it will ensure that they're applied. So it blocks any deployments that fail. And this is a new capability. We're currently working on our 2.0 release that is going to go live in about a month. This is part of it, but it's already available, and it's in the open source as well. So you can check it out today. We've got a bunch of blog posts that we just wrote recently about this policy as code feature.
Awesome. So Jeff, thanks so much. I want to wrap up this webinar. So I want to thank our sponsors, Google Cloud, for providing me the infrastructure and the resources to run this entire series. NewsStack, my media partner, most of the tutorials and articles go to the NewsStack. Foghorn, one of the Bay Area companies, which is in the Multicloud Edge platform. Portworx, a container storage company, again, a Bay Area-based startup focused on container-attached storage and cloud-native storage. So I'm pretty excited to announce the next webinar, which is going to be in the intelligence track. And this is all about getting started with Azure ML pipelines. So when you're doing ML, there is a series of steps that take place. Sometimes they happen in a specific sequence, and sometimes they happen in parallel. But every machine learning experiment or a project is a series of steps. In fact, it's a collection of multiple experiments. So Azure ML provides a capability to create these stages as a part of the machine learning pipeline. And in the next webinar, I'm going to walk you through the building blocks of Azure ML pipelines, and then I'm going to do an end-to-end demo where we acquire the data, and go through the entire pipeline of exploratory data analysis to data prep to data transformation to choosing an algorithm, hyperparameter tuning, and then deploying the model and exposing that as a REST endpoint all the way. So that's the next webinar on March 19th at 9:30 p.m. India time and 9 a.m. Pacific time. So again, you can go ahead and sign up. The registration form is available at mi2.live. I again want to thank Joe for joining me to deliver this very interesting and very useful session on infrastructure as code. Go to Pulumi and check out their SDKs and get started through the tutorials and their docs. So Joe, thanks once again.
Thanks, Jennifer, and thanks everyone for joining. Had a lot of fun.
Thank you. And that brings us to the end of the session. Very soon, this video will be uploaded to YouTube. And I look forward to seeing you in the next webinar. Thank you.